Physics. Syllabus for Neet, UG, 2025. Physics. Unit 1, Physics and Measurement. Units of measurements, system of units, SI units, fundamental and derived units, least count, significant figures, errors in measurements, dimensions of physics quantities, dimensional analysis, and its applications. Unit 2, Kinemaths. The frame of reference, motion in a straight line, position time graph, speed and velocity, uniform and non-uniform motion, average speed and instantaneous velocity, uniformly accelerated motion, velocity time, position time graph, relations for uniformly accelerated motion, scalars and vectors, vector. Addition and subtraction, scalar and vector products, unit. Vector, resolution of a vector. Relative velocity, motion in a plane, projectile motion, uniform. Circular motion. Unit 3, Laws of motion. Force and inertia, Newton's first law of motion, momentum, Newton's second law of motion, impulses, Newton's third law of motion. Law of conservation of linear momentum and its applications. Equilibrium of concurrent forces. Static and kinetic friction, laws of friction, rolling friction. Dynamics of uniform circular motion, centripetal force and its applications. Vehicle on a level circular road, vehicle on a banked road. Unit 4, Work, energy, and power. Work done by a constant force and a variable force. Kinetic and potential energies, work-energy theorem, power. The potential energy of spring, conservation of mechanical energy, conservative and non-conservative forces, motion in a vertical circle, elastic and inelastic collisions in 1 and 2 dimensions. UNIT 5, rotational motion. Center of the mass of a two-particle system, center of the mass of a rigid body, basic concepts of rotational motion, moment of a force, torque, angular momentum, conservation of angular momentum and its applications. The moment of inertia, the radius of gyration, values of moments of inertia for simple geometrical objects, parallel and perpendicular axes theorems, and their applications. Equilibrium of rigid bodies, rigid body rotation and equations of rotational motion, comparison of linear and rotational motions. Unit 6, Gravitation. The universal law of gravitation. Acceleration due to gravity and its variation with altitude and depth. Kepler's law of planetary motion. Gravitational potential energy, gravitational potential. Escape velocity, motion of a satellite, orbital velocity, time period and energy of satellite. Unit 7, Properties of solids and liquids. Elastic behavior, stress-strain relationship, Hooke's law. Young's modulus, bulk modulus, modulus of rigidity. Pressure due to a fluid column, Pascal's law and its applications. Effect of gravity on fluid pressure. Viscosity, Stokes' law. Terminal velocity, streamline, and turbulent flow. Critical velocity. Bernoulli's principle and its applications. Surface energy and surface tension, angle of contact, excessive pressure across a curved surface, application of surface tension, drops, bubbles, and capillary rise. Heat, temperature, thermal expansion, specific heat capacity, calorimetry, change of state, latent heat. Heat transfer, conduction, convection, and radiation. Unit 8, Thermodynamics. Thermal equilibrium, zeroth law of thermodynamics, the concept of temperature. Heat, work, and internal energy. The first law of thermodynamics, isothermal and adiabatic processes. The second law of thermodynamics, reversible and irreversible processes. UNIT 9, KINETICTHEORYOFGASES. Equation of state of a perfect gas, work done on compressing a gas, kinetic theory of gases assumptions, the concept of pressure. Kinetic interpretation of temperature, RMS speed of gas molecules, degrees of freedom. Law of equipartition of energy and applications to specific heat capacities of gases, mean free path. Avogadro's number, Unit 10, Oscillations and waves. Oscillations and periodic motion, time period, frequency, displacement as a function of time. Periodic functions, simple harmonic motion, SHM, and its equation, phase, oscillations of a spring restoring force and force constant, energy in SHM kinetic and potential energies, simple pendulum, derivation of expression for its time period, wave motion. Longitudinal and transverse waves, speed of traveling wave. Displacement relation for a progressive wave. Principle of superposition of waves, reflection of waves. Standing waves in strings and organ pipes, fundamental mode and harmonics. Beats. Unit 11, ELECTROSTATICS. Electric charges, conservation of charge. Coulomb's law: forces between two-point charges, forces between multiple charges, superposition principle and continuous charge distribution. Electric field due to a point charge, electric field lines. Electric dipole, electric field. Due to a dipole, torque on a dipole in a uniform electric field. Electric flux. Gauss's law and its applications to find field due to infinitely long uniformly charged straight wire, uniformly charged infinite plane sheet, and uniformly charged thin spherical shell. Electric potential and its calculation for a point charge, electric dipole and system of charges. Potential difference, equipotential surfaces, electrical potential energy of a system of two-point charges and of electric dipole in an electrostatic field. Conductors and insulators. Dielectrics and electric polarization, capacitors and capacitances, the combination of capacitors in series and parallel, capacitance of a parallel plate capacitor with and without dielectric medium between the plates. Energy stored in a capacitor. Unit 12, current electricity. Electric current. Drift velocity, mobility and their relation with electric current. Ohm's law. Electrical resistance. VL characteristics of ohmic and non-ohmic conductors. Electrical energy and power. Electrical resistivity and conductivity. Series and parallel combinations of resistors. Temperature dependence of resistance. Internal resistance, potential difference and EMF of a cell, a combination of cells in series and parallel. Kirchhoff's laws and their applications. Wheatstone bridge. Meter bridge. Unit 13, magnetic effects of current and magnetism. Savart law and its application to current-carrying circular loop. Ampere's law and its applications to infinitely long current-carrying straight wire and solenoid. Force on a moving charge in uniform magnetic and electric fields. Force on a current-carrying conductor in a uniform magnetic field. The force between two parallel currents carrying conductors. Definition of ampere. Torque experienced by a current loop in a uniform magnetic field, moving coil galvanometer, its sensitivity, and conversion to ammeter and voltmeter. Current loop as a magnetic dipole and its magnetic dipole moment. Bar magnet as an equivalent solenoid, magnetic field lines. Magnetic field due to a magnetic dipole, bar magnet, along its axis and perpendicular to its axis. Torque on a magnetic dipole in a uniform magnetic field. Para. Dear and ferromagnetic substances with examples, effect of temperature on magnetic properties. Unit 14, electromagnetic induction and alternating currents. Electromagnetic induction, Faraday's law. Induced EMF and current, Lenz's law, eddy currents. Self and mutual inductance. Alternating currents, peak and RMS value of alternating current, voltage, reactance and impedance, LCR series circuit, resonance, power in AC circuits, wattless current. AC generator and transformer. Unit 15, electromagnetic waves. Displacement current. Electromagnetic waves and their characteristics, transverse nature of electromagnetic waves, electromagnetic spectrum, radio waves, microwaves, infrared, visible, ultraviolet. X-rays. Gamma rays, applications of E.M. waves. Unit 16, OPTICS. Reflection of light, spherical mirrors, Mora formula. Refraction of light at plane and spherical surfaces, thin lens formula and lensmaker formula. Total internal reflection and its applications. Magnification, power of a lens. Combination of thin lenses in contact. Refraction of light through a prism. Microscope and astronomical telescope, reflecting and refracting, and their magnifying powers. Wave optics, wavefront and Huygens principle. Laws of reflection and refraction using Huygens principle. Interference, Young's double-slit experiment and expression for fringe width, coherent sources, and sustained interference of light. Diffraction due to a single slit, width of central maximum. Polarization, plane polarized light, Brewster's law, uses of plane polarized light and Polaroid. Unit 17, dual nature of matter and radiation. Dual nature of radiation, photoelectric effect. Hertz and Leonard's observations, Einstein's photoelectric equation, particle nature of light. Matter waves wave nature of particle, de Broglie relation. Unit 18, atoms and nuclei. Alpha particle scattering experiment, Rutherford's model of atom, Bohr model, energy levels, hydrogen spectrum. Composition and size of nucleus, atomic masses, mass-energy relation, mass defect, binding energy per nucleon and its variation with mass number, nuclear fission, and fusion. Unit 19, Electronic devices. Semiconductors, semiconductor diode, IV characteristics in forward and reverse bias. Diode as a rectifier, IV characteristics of LED. The photodiode, solar cell, and Zener diode. Zener diode as a voltage regulator. Logic gates, OR, and, NOT, NAND and NOR. Unit 20, Experimental skills. Familiarity with the basic approach and observations of the experiments and activities. 1. Vernier calipers, its use to measure the internal and external diameter and depth of a vessel. 2. Screw gauge, its use to determine thickness, diameter of thin sheet, wire. 3. Simple pendulum, dissipation of energy by plotting a graph between the square of amplitude and time. 4. Meter scale, the mass of a given object by the principle of moments. 5. Young's modulus of elasticity of the material of a metallic wire. 6. Surface tension of water by capillary rise and effect of detergents. 7. Coefficient of viscosity of a given viscous liquid by measuring terminal velocity of a given spherical body. 8. Speed of sound in air at room temperature using a resonance tube. 9. Specific heat capacity of a given, I, solid and, E, liquid by method of mixtures. 10. The resistivity of the material of a given wire using a meter bridge. 11. The resistance of a given wire using Ohm's law. 12. Resistance and figure of merit of a galvanometer by half deflection method. 13. The focal length of I, convex mirror, E, concave mirror, and E, convex lens, using the parallax method. 14. The plot of the angle of deviation versus angle of incidence for a triangular prism. 15. Refractive index of a glass slab using a traveling microscope. 16. Characteristic curves of a p-n junction diode in forward and reverse bias. 17. Characteristic curves of a Zener diode and finding reverse breakdown voltage. 18. Identification of diode, LED, resistor, a capacitor from a mixed collection of such items. Chemistry, physical chemistry, inorganic chemistry and organic chemistry syllabus for Neet 2026. Physical chemistry, Unit I, some basic concepts in chemistry. Matter and its nature, Dalton's atomic theory, concept of atom, molecule, element, and compound, laws of chemical combination, atomic and molecular masses, mole concept, molar mass, percentage composition, empirical and molecular formulae, chemical equations and stoichiometry. Unit 2, atomic structure, nature of electromagnetic radiation, photoelectric effect, spectrum of the hydrogen atom. Bohr model of a hydrogen atom, its postulates, derivation of the relations for the energy of the electron and radii of the different orbits, limitations of Bohr's model, dual nature of matter, de Broglie's relationship. Heisenberg uncertainty principle, elementary ideas of quantum mechanics, the quantum mechanical model of the atom, its important features. Concept of atomic orbitals as one electron wave functions, variation of and 2 with r for 1s and 2s orbitals, various quantum numbers, principle, angular momentum, and magnetic quantum numbers, and their significance, shapes of s, p, and d, orbitals, electron spin and spin quantum number, rules for filling electrons in orbitals, Aufbau principle. Pauli's exclusion principle and Hund's rule, electronic configuration of elements, extra stability of half-filled and completely filled orbitals. Unit 3, chemical bonding and molecular structure. Cassell, Lewis approach to chemical bond formation, the concept of ionic and covalent bonds. Ionic bonding, formation of ionic bonds, factors affecting the formation of ionic bonds, calculation of lattice enthalpy. Covalent bonding, concept of electronegativity. Fajon's rule, dipole moment, valence shell. Electron pair repulsion, VSEPR, theory and shapes of simple molecules. Quantum mechanical approach to covalent bonding, valence bond theory, its important features, the concept of hybridization involving s, p, and d orbitals, resonance. Molecular orbital theory, its important features. LCAOs, types of molecular orbitals, bonding, antibonding, sigma and pi bonds, molecular orbital electronic configurations of homonuclear diatomic molecules, the concept of bond order, bond length, and bond energy. Elementary idea of metallic bonding. Hydrogen bonding and its applications. Unit 4, Chemical Thermodynamics. Fundamentals of thermodynamics, system and surroundings, extensive and intensive properties, state functions, types of processes. The first law of thermodynamics, concept of work, heat internal energy and enthalpy, heat capacity, molar heat capacity, Hess's law of constant heat summation, enthalpies of bond. Dissociation, combustion, formation, atomization, sublimation, phase transition, hydration, ionization, and solution. The second law of thermodynamics, spontaneity of processes, S of the universe and G of the system is criteria for spontaneity. G, standard Gibbs energy change, and equilibrium constant. Unit 5, SOLUTIONS. Different methods for expressing the concentration of solution, molality, molarity, mole fraction, percentage, by volume and mass both, the vapor pressure of solutions and Raoult's law, ideal and non-ideal solutions, vapor pressure, composition, plots for ideal and non-ideal solutions, colligative properties of dilute solutions, a relative lowering of vapor pressure, depression of freezing point, the elevation of boiling point and osmotic pressure, determination of molecular mass using colligative properties, abnormal value of molar mass, Van't Hoff factor and its significance. Unit 6, EQUILIBRIUM. Meaning of equilibrium, the concept of dynamic equilibrium. Equilibria involving physical processes, solid-liquid, liquid, gas and solid-gas equilibria, Henry's law. General characteristics of equilibrium involving physical processes. Equilibrium involving chemical processes, law of chemical equilibrium, equilibrium constants, Kp and Kc, and their significance, the significance of G and G in chemical equilibrium, factors affecting equilibrium concentration, pressure, temperature, the effect of catalyst, Le Chatelier's principle. Ionic equilibrium, weak and strong electrolytes, ionization of electrolytes, various concepts of acids and bases, Arrhenius. Bronsted, Lowry and Lewis, and their ionization, acid-base equilibria, including multi-stage ionization, and ionization constants, ionization of water. pH scale, common ion effect, hydrolysis of salts and pH of their solutions, the solubility of sparingly soluble salts and solubility products, buffer solutions. Unit 7, Redox reactions and electrochemistry. Electronic concepts of oxidation and reduction, redox reactions, oxidation number, rules for assigning oxidation number, balancing of redox reactions. Electrolytic and metallic conduction, conductance in electrolytic solutions, molar conductivities and their variation with concentration, Kohlrausch's law and its applications. Electrochemical cells, electrolytic and galvanic cells, different types of electrodes, electrode potentials including standard electrode potential, half, cell and cell reactions, EMF of a galvanic cell and its measurement, Nernst equation and its applications, relationship between cell potential and Gibbs energy change, dry cell and lead accumulator, fuel cells. Unit 8, Chemical kinetics. Rate of a chemical reaction, factors affecting the rate of reactions, concentration, temperature, pressure, and catalyst, elementary and complex reactions, order and molecularity of reactions, rate law, rate constant and its units, differential and integral forms of zero and first order. Reactions, their characteristics and half-lives, the effect of temperature on the rate of reactions, Arrhenius theory, activation energy and its calculation, collision theory of bimolecular gaseous reactions, no derivation. Inorganic chemistry. Unit 9, classification of elements and periodicity in properties. Modem periodic law and present form of the periodic table, S, pages D and F block elements, periodic trends in properties of elements atomic and ionic radii, ionization enthalpy, electron gain enthalpy, valence, oxidation states, and chemical reactivity. Unit 10, P block elements. Group -13 to Group 18 elements. General introduction, electronic configuration and general trends in physical and chemical properties of elements across the periods and down the groups, unique behavior of the first element in each group. Unit 11, D and F block elements. Transition elements. General introduction, electronic configuration, occurrence and characteristics, general trends in properties of the first row transition elements, physical properties, ionization enthalpy, oxidation states, atomic radii, color, catalytic behavior, magnetic properties, complex formation, interstitial compounds, alloy formation, preparation, properties, and uses of K2Cr2O7, and potassium permanganate. Inner transition elements, lanthanoids, electronic configuration, oxidation states, and lanthanoid contraction. Actinoids, electronic configuration and oxidation states. Unit 12, Coordination compounds. Introduction to coordination compounds. Werner's theory, ligands, coordination number, denticity. Chelation, IUPAC nomenclature of mononuclear coordination compounds, isomerism, bonding valence bond approach and basic ideas of crystal field theory, color and magnetic properties, importance of coordination compounds, in qualitative analysis, extraction of metals and in biological systems. Organic chemistry. Unit 13, Purification and characterization of organic compounds. Purification, crystallization, sublimation, distillation, differential extraction, and chromatography, principles and their applications. Qualitative analysis, detection of nitrogen, sulfur, phosphorus, and halogens. Quantitative analysis, basic principles only, estimation of carbon, hydrogen, nitrogen, halogens, sulfur, phosphorus. Calculations of empirical formulae and molecular formulae. Numerical problems in organic quantitative analysis. Unit 14, Some basic principles of organic chemistry. Tetravalency of carbon, shapes of simple molecules, hybridization, S and P, classification of organic compounds based on functional groups, and those containing halogens, oxygen, nitrogen, and sulfur, homologous series, isomerism, structural and stereoisomerism. Nomenclature, trivial and IUPAC, covalent bond fission, homolytic and heterolytic, free radicals, carbocations, and carbanions, stability of carbocations and free radicals, electrophiles, and nucleophiles. Electronic displacement in a covalent bond. Inductive effect, electromeric effect, resonance, and hyperconjugation. Common types of organic reaction: substitution, addition, elimination, and rearrangement. UNITS 15, hydrocarbons. Classification, isomerism, IUPAC nomenclature, general methods of preparation, properties, and reactions. Alkanes, conformations, Sawhorse and Newman projections, of ethane, mechanism of halogenation of alkanes. Alkenes, geometrical isomerism, mechanism of electrophilic addition, addition of hydrogen, halogens, water, hydrogen halides, Markovnikov's and peroxide effect, ozonolysis and polymerization. Alkanes, acidic character, addition of hydrogen, halogens, water, and hydrogen halides, polymerization. Aromatic hydrocarbons, nomenclature, benzene, structure and aromaticity, mechanism of electrophilic substitution, halogenation, nitration. Friedel, Kraft's alkylation and acylation, directive influence of the functional group in mono-substituted benzene. Unit 16, organic compounds containing halogens. General methods of preparation, properties, and reactions. Nature of CX bond, mechanisms of substitution reactions. Uses, environmental effects of chloroform, iodoform freons, and DDT. Unit 17, organic compounds containing oxygen. General methods of preparation, properties, reactions, and uses. Alcohols, phenols, ANDETHERS. Alcohols, identification of primary, secondary, and tertiary alcohols, mechanism of dehydration. Phenols, acidic nature, electrophilic substitution reactions, halogenation. Nitration and sulfonation. Reimer, Tiemann reaction. Ethers, structure, aldehyde and ketones, nature of carbonyl group, nucleophilic addition to greater than C = O group, relative reactivities of aldehydes and ketones, important reactions such as nucleophilic addition reactions, addition of HCN, NH3, and its derivatives, Grignard reagent, oxidation, reduction. Wolff-Kishner and Clemenson, the acidity of hydrogen. Aldo-L condensation, Cannizzaro reaction. Haloform reaction, chemical tests to distinguish between aldehydes and ketones. Carboxylic acids, acidic strength and factors affecting it. Unit 18, organic compounds containing nitrogen. General methods of preparation, properties, reactions, and uses. Amines, nomenclature, classification structure, basic character, and identification of primary, secondary, and tertiary amines and their basic character. Diazonium salts, importance in synthetic organic chemistry. Unit 19, BIOMOLECULES. General introduction and importance of biomolecules. Carbohydrates, classification, aldoses and ketoses, monosaccharides, glucose and fructose, and constituent monosaccharides of oligosaccharides, sucrose, lactose, and maltose. Proteins, elementary idea of amino acids, peptide bond, polypeptides. Proteins, primary, secondary, tertiary, and quaternary structure, qualitative idea only, denaturation of proteins, enzymes. Vitamins, classification and functions. Nucleic acids, chemical constitution of DNA and RNA. Biological functions of nucleic acids. Hormones, general introduction, Unit 20, principles related to practical chemistry. Detection of extra elements, nitrogen, sulfur, halogens, in organic compounds. Detection of the following functional groups: hydroxyl, alcoholic and phenolic, carbonyl, aldehyde and ketones, carboxyl, and amino groups in organic compounds. The chemistry involved in the preparation of the following: inorganic compounds, Morse salt, potash alum. Organic compounds, acetanilide, p-nitroacetanilide, aniline yellow, iodoform. Thanks for watching the video. Biology syllabus will be uploaded in next video. Do like, subscribe and share the video.